So we're about to have our Unit 1 test. After this lesson, we'll have a review and then a test. So let's see what's in store for us here. So we're talking about outliers. So we've mentioned outliers. You can see that point on the left. Looks like it would probably be an outlier near 21 there. But how do you tell if it's an outlier or not? By the way, this is a dot plot of LeBron James' average number of points scored per game in each of his first 16 playing years. I'm kind of curious now. I wonder if that 21 is his first year, or maybe it's been his last year. Maybe he declined towards the end. I'd be surprised if in the middle of his career he had an average of 21, unless he was hurt. I'm guessing that's his first year, but I don't know. But data always, provokes questions typically. I have a name for this. These are two different formulas. This one on the left, the low outliers, I call it the lower fence, is equal to that. That's what the fence mark is. Anything smaller than that is an outlier. And the upper fence is Q3 plus 1.5 IQRs. And that's anything above that upper fence is a high outlier. So technically they are inequalities, but I like to call them lower fence and upper fence. They're two separate little formulas that we'll use. A couple of them, 21 for sure is an outlier, maybe 32 there. I wonder if that happened during I don't know, it could have been anything. Why look for outliers? Well, those are interesting. How do you explain the outliers? Was he just really bad one year? What happened? Maybe he felt sick. I don't know what happened. So they may be inaccurate data values. Sometimes that happens. Sometimes we just type in the wrong number. They could be some kind of remarkable occurrence one way or the other, right? So those are always interesting. And outliers have a big influence on mean and range and standard deviation. So all those are heavily influenced by an outlier. So let's make sure we understand it and that it's right and so forth. So here's the numbers. So I'm going to put this in my calculator because I want to do some of this data crunching myself here and show you how you would do it. So LeBron is 20.9. I don't think I mentioned this last time, but some people will stop right there. I don't know if you noticed what I did different. I typed the number, but I didn't press enter or go to the next cell. And it doesn't know I typed the number in yet. So you have to go to the next cell or press enter or get out of that cell. But there should be, if I did this right, 15 numbers. Uh-oh. I have a feeling I didn't do it right. So 20.9, 27.2, 3. Okay. Oh, there's two 25.3s. Doesn't matter the order. Now I have the right number of times. That happens sometimes, so it's really easy to miss a number. My brain went right to the right of 25.3 instead of repeating 25.3. And so that protects you from that. We're going to do the one menu 611. Oh, wait. Let's do this. Go to a calculator page. So home, calculator, menu, 611. I'm going to say OK and choose the name of this is LeBron. So that's all the data there. So it says 1.5 times the IQR rule. Okay, so IQR would be 27.95 minus Q, that's Q3, minus Q1, which is 26.55. So that's IQR. Multiply that by 1.5. And then you have to add or subtract that from either Q3 or Q1. So Q3 plus that value or Q1 minus that value. So I'm going to start with Q3 is 27.95 plus the 2.1. That's my upper fence. My lower fence is Q1, which is 26.55, minus that amount. That's my lower fence. So my lower fence is anything below 24.45 is an outlier. Anything above 30.05 is an outlier. So we definitely have an upwards outlier at 31.4. And anything less than 24, I know there was a 21-ish in there, wasn't there? 20.9. So 20.9. So those all seem to be outliers. Let's see what we did. So they found Q3, Q1. They subtracted. They got 24.45 and 30.05. So 20.9 was his rookie season. It's nice to know. And then he had one season of just so high, 31.4. That's pretty solid. Jordan-esque there, because Jordan used to score a ton, I feel like. Okay, 5-number summary. So what do we do with those 5 numbers? So you make what's called a box plot here. So you can see at the bottom of the screen is a box plot. Just gonna make sure you can see it, so make it go a little bit lower so you can see the title of that box plot. So you can see the box there. If you see the median is the middle line there is called the median. That's the 50% point. 50% of the data is below or above that median. Q1 is the 25% point. So 25% is in that whisker to the left. 25% is between Q1 and the median. Q3 is at the 75% point. 75% of the data is below Q3. It's like 70. It's like 3/4, right? Quartile 3. And 25% is above. And so those are the 5 numbers we need. We need the min, wow, which is 20.9. The max is 31.4. Do you notice this? They put a dot there or a point there, but they didn't connect it to the whisker. That's because they want to identify that as an outlier. Your calculator does that automatically, which is actually really nice. And they use the 1.5 IQR method of calculating outliers. There are different methods out there, actually. So if you think about the 1.5 IQR, what they're doing is they're taking IQRs from Q3 to Q1. So it's basically that box. You're doing 1.5 times that box in either direction from Q3 or Q1, respectively. Box plot is a visual representation of the 5-number summary. 5-number summary are minimum, Q1, median, Q3, and max. And by the way, it's always, in your calculator, it's always those mostly last 5 numbers. So min, Q3, so forth. You can see those last 5 numbers are the summary there. I just drew a picture of it there. The IQRs form a fence. Anything outside that fence is an outlier, and there are 2 of them. Drawing the box plot, this is what it would look like. Whiskers extend to the last data value that is not an outlier. So you find the last data value that's not the outlier, that's as far as the whisker will extend. Mark separate points as outliers. Good. Okay, so we're going to compare to parallel box plots. So the parallel means they have the same scale, but the box plots are different. Their spread is different, all kinds of things. So compare the distributions. So let's compare the centers. So the median of Apple is greater than the median of Samsung. And I guess these are the ratings for those 2. The IQR for Apple is smaller than the IQR for Samsung. That's the width of the box, basically. You might say we could take a guess. Box plots are not great at shape. We could take a guess that these are both skewed left, but you don't really want to use box plots for shape. Let's see what they said. Well, they did. It's just a little, just trust me, you're going to get to some where it's like, it can be deceiving. So outliers, it does look like Apple has 2 outliers, whereas Samsung does not have any outliers. There's no separated points there. Center, again, medians, you're talking about the median, which one's larger than the other. And variability, you're going to use IQR to talk about that. Could use range, but IQR is better. Be careful to use comparative language. You're comparing which one's greater or less. We already talked about that. Although we didn't do, okay, so let's do this. Let's graph this in our calculator, the box plot. It's actually pretty cool. So I think this is the LeBron James one. So we're going to go to here, data statistics, click there, and choose LeBron. It does a dot plot, but maybe you didn't realize it does this. If you hit menu and go to plot type and change it to a box plot, oh my goodness, it does the 5-number summary. You can actually hover your cursor over that and see the number. You can see Q1, which is one of the 5-number summaries, the median, Q3, the max, 31.4, which is another outlier. So it does nicely create that box plot for us as well. They're not hard to create by hand if you have the 5-number summary. 5-number summary is the key, actually. You can do parallel ones just by, I think the way you do that is you right-click on X, or you could go here, menu, plot properties, add X variable. If you do that, you can add another X variable. This is not going to make any sense. I'm going to add angles, and it'll draw a parallel box plot with both those guys. It doesn't make sense to do parallel box plots with this data, but you still get the idea. You can add an X variable there. Okay, you're done with the lesson. Just a few more sample problems if you want to practice here. So catamarans are boats built with 2 hulls, and they're stable. And so here are the freshwater capacities of a sample of 19 ocean-going catamarans. So use the rule to identify if there's any outliers, right? So you first have to either do one variable stats in your calculator, which is what I would do. You already get the Q3 of 206 and the 145 as your Q1. Subtract those 2 numbers to get the IQR, which is 61. Apply the formula, right? So Q1 minus 1.5 times that number, 61. And then Q3, which is 206, plus 1.5 times the IQR, which is times 61. You get the upper and lower fence. That means 53.5. Anything lower than that, you've got an outlier. Anything above 297 is an outlier. There are no outliers because no values are below or above those 2 numbers there, respectively. Okay? If you want to compare 2 box plots, you can do that. Compare the distributions of these seasons. So to do that, you want to use comparative words. The shape is skewed to the right for 1968. But 1978 is approximately symmetric. So it's not perfectly symmetric, but it's appropriate to say approximately symmetric. There is one high outlier for 1968. There are no outliers for 1978. I wonder who that was. Hit so many home runs. Had a greater median in 1978, 110, which is greater than 97. So 1978 has a greater median. And the IQR, you can see clearly 1968 has a larger IQR than 1978. The box is larger there. That's called the middle 50% or the IQR. That's your lesson for today.